Okay, the goal here is to actually create equations that are consistent or inconsistent. In other words, create equations that have one solution, infinite solutions, or no solutions. For example, in this first problem, they give you 3x minus 8y equals negative 4, and they want infinitely many solutions. So that just means, if you do this equation, you, let's say, double everything. You get 6x minus 16y equals negative 8. These are the same equations, just scaled differently. If you tripled everything, that would still be true. You get 9x minus 24y equals negative 12, same thing. So in these problems, they're asking you to identify the scale factor between the coefficients and then scale up accordingly. Here they give you negative 4 and 6. So to find the scale factor, right, I just think, well, I know that 6 divided by negative 4 is the same thing as 3 over negative 2, or negative 3 halves. That just means that all the numbers in the second equation equal the numbers in the first equation times negative 3 halves. For example, negative 4 times negative 3 over 2, what's that? Right? Just to check my math here, 2 negatives multiply to get a positive. 4 times 3 is 12, over 2 is 6. So that means if we took negative 4, which is our first number here, multiplied it by negative 3 halves, we do get, right, times negative 3 halves, we do get 6. So then I just do that to each coefficient in each term. So we take 3, right, we have 3 times negative 3 halves, same scale factor, we get negative 9 over 2 when I type that number in here. Then we have negative 8y, so negative 8 times negative 3 halves equals positive 24 over 2. Right? 8 times 3 is 24. It's 2 negatives multiplied to a positive, and that's just 12. That number goes here, and I have two equations with infinitely many solutions because one is a scaled up version of the other. The same thing is true here. In this problem, they want to know how we can, what value of a will give us no solutions. So the idea is that in the first equation, they give you 4x plus 5y equals negative 2. And the second, negative 4x minus 5y equals a. Okay, well, the idea is you can't have two equal expressions equal to different things. The expression I'm looking at in the first one, it's 4x plus 5y, and then its opposite, negative 4x minus 5y. So that means whatever this expression equals here, since we have its opposite down here, it should equal the opposite result. So 4x plus 5y equals negative 2. Negative 4x minus 5y must equal a positive 2, the opposite of negative 2. So one of the choices they give you is 2. Well, if a equals 2, these would be two equal expressions. They would have infinitely many solutions. However, if it equals any number other than 2, the first choice, which is the answer, right, not the second, well, any other number would mean you have two expressions that equal different things. So, for example, if the second expression read negative 4x minus 5y equals 10, well, this is the opposite of the first expression, but it equals a different number. So these can't have any common solutions. For example, if I took the first equation and took the opposite of everything, negative 4x minus 5y equals positive 2, which is what we should get. Here, negative 4x minus 5y equals 2, and here, negative 4x minus 5y equals 10. That can't be possible. You can't have negative 4x minus 5y being the same expression twice, equaling two different things. That won't happen. So if it's any number except 2, there are no solutions here. So here, which of the following choices of C will result in a system of linear equations with one solution? Well, here, the answer is any number, right? And that's just because if you think about what's happening, right? In the first equation, we have negative 3x plus 3y equals 2. In the second, we have negative 5x minus 3y equals c. Because there's no single number that can multiply negative 3 by to get negative 5 and 3 to get negative 3, right? Because it doesn't exist. There's no number that can do that. For example, to get from 3 to negative 3, we'd have to multiply by negative 1. But doing that would cause negative 3 here to become positive 3. Because there's no single number or combination of numbers that does this, These two lines are completely different. It's not that one is a scaled up or a scaled down version of the other, like in the other cases. So any number here will give you will result in a linear equation with one solution. And if you're not sure, they give you choices around to play with. Like in the first one, they give you -2. Well, if you plug in -2, you would see that you get one point. But then you realize, oh, here they say any number except -2. Well, that can't be true because -2 works. Any negative number, if you're not sure, try a positive number. And you can do it. Try a positive number for C, anything you want. And you'll see that there's exactly one solution for these two lines. Thanks.